All right. Class. Oh, wow. Okay, that was weak. That was weak. Danny, where were you on that one? Needed you there, Denny. We need that deep bass. All right, so we're gonna finish these up, but now this one right here is super ugly. Doesn't this look a whole lot like that last problem that we did? So yeah. Now, I went through and did that problem the long way, and then came back and did it the short way. Which way was the short way? What rule was that? The
Log.
Yeah, the log rule, right? ln and log use the same rules because they are the same. ln is just log base e. So that's why it's referred to as natural log. Now we're going to do the same thing for this, but we're gonna go crazy on this one. So I am going to ln both sides first. So I'm going to take the ln. So it's like the same as multiplying both sides by the same number. I'm going to ln both sides. So this is now going to become ln of y is equal to ln of x squared times, I'm going to rewrite this, 5x plus 1 to the 1/2 all over 3x minus 2 to the third. Now, because y is now part of my problem, it's part of my equation, this now turns it into an implicit differentiation. It's going to be implicit differentiation. That means I'm going to have a y value, and I'm going to also have a dy dx. So I want to try and solve for the dy dx. So let's go ahead and do this. So take the derivative using implicit differentiation. What is the derivative of ln y? What's the derivative of ln x? 1 over x. So what's the derivative of y? 1 over y. No. Dy dx.
Yeah,
Dy dx. Because it's implicit, I am no longer just doing x's. I'm doing a y when everything else is in x's. So, very good. So this is going to turn into 1 over y times dy dx. Now, before I go through and do all this, I'm going to do this, but let's separate my ln's first. So across the top, if things multiply on the inside, what does that mean? It turns what for my ln? What am I going to do to my ln's?
Oh, apple.
It's addition, right?
Oh, okay.
And the quotient, the bottom, if I'm dividing, that's going to be my.
Subtraction.
There we go. So it's going to turn into ln x squared plus ln of 5x plus 1 to the 1/2 minus ln of 3x minus 2 to the third. Okay, I still haven't done my derivative yet, though. I haven't done my derivative yet. That's important. These aren't equal right now. So these are not equal until I do my derivatives. So let's take the derivative of the right-hand side now. So before I write this, okay, I could do this as a chain rule if I want to. Okay? Now think about it. So I want you guys to try and mental math this real quick. Okay? What would my u be in this first one right here? What would the u be in this first one? what is it? X squared, right? So x squared. So u prime would be
2x.
2, okay, yeah. And then times the derivative of ln u, right? Which is?
2x.
No, it's not 2x. What's the derivative of ln u? 1 over u, or 1 over x squared, right? So, mental math here, okay? I have 1 over x squared times the derivative of u, which was what? Remember, what was u? And so it gave you 2x, right? So now, in your mental landscape right there, okay? So think about it. So on top, I have 2x, very good. And then on the bottom, I have x squared. So what's going to happen there?
Cancel out that.
Cancel out x, I'm left with
Over x.
2 over x. Okay, there's a reason why we did this, okay? We did this, and I have you do this because their same rule applies when we're actually dealing with exponents and log rules. Exponents and a log rule. What do I do with my exponent if I have a log?
What do you do with your exponent if you have
Like this one right here. So what would I do with that 2 if I have that ln x squared? Where's that going to go?
the front?
To the front, because the log rule says the exponent moves out front, right?
Yeah.
Okay, and so it would be 2 ln x.
You write that.
I'm going to.
I don't know.
Okay, it's 2 ln x, and the derivative of ln x is 1 over x. Didn't we just come up with 2 over x again? Now, but this time we did it as a log rule. So we did it using chain, and that's why I was having you guys do the mental math on this. Okay? Right there. And now I'm going to show it using my log rules for this, because we did it using the chain, and it still works out to be the exact same thing. But it makes life a little bit easier if I just move my exponent to the front using my log rules. So this is going to be 2 ln x, because my exponent comes out front. And the derivative of 2 ln x is 1 over x times,
2.
which is
2 over x.
2 over x. That's what I have right here. So 2 over x. So item by item, step by step, even if I use a different method, if I use the chain rule, or if I'm using these log rules, same thing's going to happen. And now using that information, what can I do to fix this one over here? The next one. What would I do to rewrite this second one here? Let me change up colors so we can see. This second one here. What can I do with my exponent? Yeah, what do I do with the exponent?
In the front.
Out front, right? So it turns into 1/2 times ln of 5x plus 1. I'm still going to have to deal chain rule here, right?
Yeah.
Yeah, because on the inside I don't just have x by itself, so therefore I'm going to have a chain rule in there. So I'm going to bring down my plus 1/2. What's the derivative of, remember, it's going to be a chain rule, right? What's the derivative of 1 over, in this case it would be x, right? Or u. 1 over u would be, I'm sorry, ln u would be 1 over u, right? Yes? So this is going to be 1 over u, but my u in this case is going to be what? 5x plus 1, right? Times the derivative of the inside, which is? Yep. And I'm gonna put 5 over 1 just so we could have a placement here. Now, same steps right here. Same steps. So, what am I gonna do with that 3? Goes out front, right? And then it's still gonna be a chain rule here. Okay, let's see if you guys could actually help me with this. So, are you ready? You're gonna tell me what my answer is gonna be here. 3, very good. Okay, but 1 over 3x minus 2 times 3. Very good. Good job. See, got that mental math going on. The brain is awake this morning. Or are you on that, Tater Tot? Okay. All right, so now all this here is now equal to the left side, which is 1 over y dy dx. Now, is my dy dx by itself? No, it's not. It's not by itself. That's why this is complicated here. Tater Tot, I need you following. We did some new stuff. This one became, because I complicated it in the first place by ln'ing both sides. To try to make all my craziness on the inside go away, to simplify it into small pieces. Now, what would I do to get rid of my y that's over here in the denominator on the left-hand side? Multiply both sides by y, right? Okay, so I'm going to run out of room here, but I will do this one right here. So I'm going to multiply both sides by y. So on the left side, it's going to cancel. I get dy dx equals y times 2 over x plus, now let's put this second one, this blue one right here together. What fraction is going to be out front? Fraction. Your friends, the number. Not 1/2. Not 5. What's 5 times 1/2? How about 5 halves? 5 times 1 is 5. 5 times 1 is 5. 2 times 1 is 2. So 5 over 2, right? Yeah. Times, okay? And on the bottom is my 5x plus 1. There we go. Two times 5x plus 1. Okay. I'm just setting them, I'm putting them there. I could distribute if I want to, but I really don't want to.
No, because I thought you were.
No.
Think of it as a numerator.
Okay. All right. Next one is going to become minus. This one could be just
9 over.
Yep. 9 over 3x minus 2. Well, wait. There's more. I know you guys hate me now. It's just a longer process. There's one last thing I have to do. I don't want y in my answer. Do I know what y is equal to? The original problem, right? Yeah. Y is equal to the original problem, isn't it?
Yeah.
So, this is y times all of this. All I have to do is replace. So I'm going to go that I have dy dx equals, my y was x squared 5x plus 1 3x minus 2 to the third times 2 over x plus 5 over 2 quantity 5x plus 1 minus 9 over 3x minus 2. So this one, we had to complicate the problem some more to make it easier, and it just added more steps. Otherwise, when we did this one, we had a product, we had a quotient, and each of them had a chain. So trying to simplify all that into different parts. So sometimes the easiest method is the longer method. And with that one right there, you know what? I want to see you guys actually working on this. Okay, here's actually the step for step doing these. And before we get into this, I want to see you guys actually practicing the homework, because a lot of people are not, because we're not working on stuff in class. So, and I'm hoping we will actually eventually start having advisory again, where I could see you people come in and get some work done. So like, share, and subscribe. Hit that notification button. Support my channel.